Wow, that last minute is always the longest minute because I'm sitting here waiting to push the start button. And so here we have begun. So welcome everybody once again to Astronomy Daily Live. So this is just a daily gathering together of some friends around the world to sit and chit chat about astronomy and space and science and other nerdy things. Always get interjected into conversations. Um, but yeah, this is just an ever-growing, nice, fun, casual get-together to talk about just a very well, an area of common interest. In this case, the universe, right? I've been interested in the universe and, you know, why is it here and what is it doing, and all of that my entire life. And so very early on, I realized that it's like, okay, well, I want to study everything. I want to know everything. So uh, I mean, is there a pathway to being able to do that? And the pathway was the pathway of astronomy. So I got on to that path. I jumped on path, pushed the button, and that rocket launched straight up. Bam. Um, an unbelievable uh, amount of thrust for many years, um, many refuelings along the way. Um, but yeah, I'm eventually landing as an astronomy student at the University of Arizona, doing all kinds of really cool things, and um, actually becoming a member of the staff there, working on high resolution imaging and adaptive optics, and making big huge mirrors, and doing all kinds of really cool things. And and yeah, so had had a lot of fun with that. Decided to sort of go it alone and have some fun with that, which for the most part has been pretty interesting, pretty interesting. So yeah, so hope everybody's doing well today, tonight, wherever you might be. So here, cheers. This is a nice full mug of hydrogen hydroxide. So cheers. It's heavy. It's feeling extra heavy today. Hmm. Excellent. All right. Well, I know that Bobby said that he was probably not going to be on the live stream today. He had some kind of prior engagement, so it's just going to be well, it might be a little less lively than what it normally is because it might just be me, and so my apologies. All right, well, I hope everybody's doing well out there. Everything's good here. It's supposed to tomorrow night here, it's supposed to freeze. So, uh, um, so yeah, excuse me, for this time of year, for it to be freezing, for us to have to, at least contemplate the idea of covering some plants that we now have outside. Um, and wow, that is going to absolutely decimate the any of the fruit trees around here. It is going to completely destroy them all, because I can only imagine that they've probably been flowering out, and this cold is going to completely destroy them. so we may not have uh, a lot of fruit coming out of this valley. This valley does really, really, really good with like peaches and pears and apples. Um, as long as you have the water, uh, these things grow really, really well here. Um, but once in a while, we get this kind of thing where it gets cold really late, really late. This is the latest we've we've been here at this location. This will be almost 14 years. 14, yeah. Um, and we we've had snow the first part of May. We've had snow. But this one, there's a possibility that we might get snow on, I think that'll be like the 21st. So that's just absolutely crazy. So yeah, but that's, I mean, I really, really appreciate that. I like uh, that kind of change. Um, Now, I mean, I think that I would be like everybody else in that, there's probably some kind of limit to the amount of change that I could tolerate. Um, so, yeah, I don't know what that would look like in terms of weather or climate or anything. Um, but, you know, uh, a whole lot of water here is probably not a good thing. Not a whole lot. Um, so yeah, yeah. Anyway, it's just interesting, to think about. But yeah, it's gonna be really cold. It might freeze. We might have frost um, on the outside on May 21st. So absolutely, absolutely amazing. Yeah. All right. Well, other than that, everything's good here. We've got clouds. We've got the kitty cat looking out, she's looking out the window there. Just big yawn. Yeah. So she's just checking out the birds. There's a big bush right outside of the window there, and lots of birds hang out there. And she just absolutely loves watching those birds, because man, there's just something about birds that just makes it great. But yeah, she doesn't. I guess she doesn't want to be on camera, so I'll just flip that back to there. So hey, check me out is live on Twitch right now. So I'm thinking that I don't know how much longer she's going to be on, but this is her sort of graduation celebration, and she is playing her her uh, her bowls and her gongs, and she has chimes, and a few other interesting sounding things. Very, very soothing, very, very nice, very, very chill. So I'm kind of thinking that um, this might be a shortish live stream, because yeah, I'm thinking I'd like to get over there too. But Hey, I definitely want to say hi to Tom in the chat and PageMaster. Just like Johnny 5, need more input. Same goes with me, more input. Yes. Yeah, um, about starting early. I will do that from time to time, but usually I've I've got my timing down now such that at 1:45 UTC, I start the process, and um, most of the time, I go through the process. I get a nice full mug. Make sure all the lights are on. Make sure that some friends are in here and some friends aren't in here. Make sure that there isn't any incriminating evidence behind me of any sort. That's extremely important. Um, and and uh, and it just so happens that doing all that puts me in this chair in front of this camera at about 1:57 once I get everything done. So I've got 3 minutes to just sort of wait, and it's an absolute fact that those first 2 minutes go by really, really, really fast, and that last minute just takes absolutely forever. Very cool, very, very cool, PageMaster. So yeah, you can go to, and I'm sure you know it. It's isn't it called dsnnow.com or something? Um, what is it? I'm gonna race you. See if I can DSN now. Um, or is it now DSN? Oh man, let's see, I'm gonna lose DSN now. Spacecraft. Space Now. DSN Space Now. Okay, there it is. Copy. Let's see if PageMaster already did. Oh, there we go. I've got him. Gotcha. All right, let's since PageMaster brought up the Deep Space Network, let's go over there and take a look and see. And it's probably not going to look incredibly great here, but I'm going to show it anyway because we're all right with all that. We have to deal with the technology a little bit, but so let's see. Here. So yeah, so cool. One of the 34-meter telescopes at Madrid is talking to Voyager 1, and you can sort of see down here in the bottom right. So here's what it is talking to. So round trip light time is 1.67 days. Yeah. 21.67 billion kilometers away. So it's talking to DSS 54, which is this one. And that's how it's pointing. They have a little graphic here showing the telescope itself, the radio dish, and where it's pointing in the sky. So it's pretty amazing, the kind of information. And there's even more information. Okay, now they have a you know, how much data are they getting? They're getting 159 bits per second. There is the frequency. If you want to tune in, you can try, because the signal is at negative 159.85 dBm, which is that many kilowatts. So that's well, that's why they need a 34-meter dish. So they've got a ups, oh, okay, down signal. Okay, I guess there's sort of two down signals right now. One's the carrier. Okay. Yeah, I mean, it's um, it's a very dynamic thing. It changes. Um, so I think they have a carrier, and then they have the signal itself. I'm not quite sure how all that works. But so here's what the rest of the Deep Space Network is talking to right now. So also in Madrid, it looks like they're getting communication from MMS1. So I'm not quite sure what MMS1 is. Not familiar with that name. It's very, very close. It's about the distance, well, twice the distance, well, no, about the distance to the moon. Yeah. So not quite sure what MMS is. MMS1. If anybody in chat knows, that'd be cool. Anyway, so they're getting 1.25 megabits per second at 2G. And you can see that this is four orders of magnitude brighter, right? I mean, this is essentially a brightness. It's just how much power, right? So, but it's 4 orders of magnitude larger than Voyager 1. So let's see. So that's Madrid. I'm not quite sure when it says, there's a name above the thing here, but there's no little wiggly things. So I'm not quite sure if that means that this thing is locked on to Voyager 1 and just at this moment isn't sending anything up or down. That's probably what that means. So let's see, down in Canberra, they've got the big 70-meter dish looking at something called DSN. Oh, it's testing. Oh, okay. So they're in some kind of testing mode. It's 7.16 gigs. Look at the power transmitted, 19.78 kilowatts. So they are pushing out almost 20 kilowatts of power out that sucker. That's pretty amazing. But that's what they have to do in order for the spacecraft to be able to get enough signal to figure out that it's actually a signal. We got to push out a lot of power here. So they're receiving a carrier of some sort, and they're also sending a signal out, and just some kind of test, I guess. So number 35 down in Canberra is looking at Maven, is talking to Maven, which is at Mars. And number 36, also in Canberra. What is that? Geotail. I don't know if I don't think I've ever heard of Geotail. Oh, maybe. Is that a spacecraft that? No, I don't know what that is. We'd have to look that up. Let's do it. Let's do it. I think we've looked at this before, but maybe not. Yeah, something rings a bell. So it's just observing Earth's magnetosphere. I think that maybe we went so far here as to look at some of the data. I don't remember. Oh, so it's a okay. So it's a Japanese and American co-op, collab, as they say. Cool. So I don't know if we went over there or not, but oh wow. So this is really, really old school website stuff. But wow, there is a database. Uh, let's see. Let's see if we can. Let's see if we can get any data here. Interactive plot, ASCII listing, clips list. Oh man. MGF high resolution. Magnetic field data. So that's always kind of interesting. I don't know. I don't know what dates to choose. But let's just assume that those are the dates that are available. So I don't know. Let's just do 2001. Let's go September 18th, 2001. And we'll go for an entire day. Right, so the start time is going to be 0 something. Don't know if that's UT or local. I have absolutely no idea. But it's going to go all the way around. That goes to 24. So I assume that that's what they mean by one entire day. So coordinate system. Oh, it doesn't really matter. It doesn't. No. Select an editor. So the Geotail satellite has 2 editors on board. The editor A data are only acquired with the real-time operation in UDSC or USC, Japan, while the editor B data are continuously recorded in the onboard tape recorders for 24 hours and are dumped to the NASA JPL Deep Space Network stations. Oh, I don't know. Let's just do editor B. Okay. So here we go for September 18th, 2001. I just arbitrarily chose that. Absolutely no reason to choose any other date. So here we go. Submit. It's working. Oh, excuse me. Well, that was a pretty good one. That was maybe an 8. Okay, so here's some data. I don't know what it is. We can we can copy this. Yeah, save link as. Let's do that. Uh-oh, I have a kitty that doesn't sound very happy. Oh man. 20. So save that. I'm going to go over here. Let me get myself situated here a little bit. As I said, you know, there is absolutely no point in self-incriminating. So what I want to do is I want to go over there. Hang tight. Astro. 1, 2, 5, 20. Okay, and now I'm going to unzip that. Whoop. Maybe it's a G unzip. Yeah. Okay, so that is unzipping a pretty large file. 96 megs. So here I will show you what I'm seeing now. I can do that with no incriminations. Share my screen again, hide that away. Check the chat really quick. PageMaster's throwing stuff up. Magnetospheric multi-scale mission. Cool. Oh, very cool. Very interesting. Thank you, Tom. Yeah. Yeah, pretty nice. Pretty nice. Okay, cool. Anyway, so this is what this is where I am here, and I've got this file. It's just a single file, and as you can see, here's a year and a month and a date. So yeah, and so we can look at this. We can just do it like this, and you can see that there's what looks like a lot of data. I don't know if this is day 261 here. There's just tons and tons and tons I mean, there are so many lines here. Oh, I don't know how to read that. Let's do it this way. Oh. So there's like 1.4 million lines. So yeah, this is a lot of data. What we can do, I think there was a description data format here. So let's look at that really quick. That will tell us exactly what we want to know. And what I just want to do, I just want to plot the magnetic field strengths in X, Y, and Z. And I just want to sort of see what those look like over the course of a day on just an arbitrary day. So yeah, okay. So it's going to be column 6, 7, and 8. So we can sort of look here and see what that looks like. So here's column 1, 2, 3. Sorry. So 1, 2, 3, 4, 5, 6, 7, 8. So these 3 are the ones that we're going to be looking at. And these are the magnetic field strengths in X and Y and Z in units of nanotesla. So they're actually making some measurements here, looking at the changing magnetic field strength. So one of the things that we can do is just plot this X, Y, Z and see what it looks like. That's a lot of data points, so it might look a little funny at first, but we can sort of play around a little bit, and see what we can do here. So the first thing I need to do is I need to get rid of that first row. You see that will confuse my plotting program. So okay, so now that's done. It's a big file. Okay, so let's just take a quick look and see what the whole thing sort of looks like. Now, I think it's going to look pretty messy, but then we can sort of zoom in and move around a little bit and see if there's anything else interesting. So yeah, just a warning, this first little bit could be pretty ugly. So we're going to do a 3D plot. And we're going to go like that using, it was 6, 7, and 8. 6, 7, and 8. 6, 7, 7, 8. Point type. I'll make them really small. Black. I have absolutely no expectation here whatsoever. So here we go. It's going to take it a little while because that's a lot of data points. I'm going to try to move this over here. It's taking it a while to render it onto the screen. The suspense is killing me, but I'm going to take a nice gulp of water here. HOH. Okay, there it is. So one of these is the X direction, one is the Y direction, and I think this is the Z direction. So we can actually move this thing around, but it's probably going to move really slowly because it has to re-render all those points every time. And I think, GNU plot is really, really well written because I think it does worry a little bit about, how memory is allocated. And I think that they found some clever ways to manipulate data in memory, so you can sort of have this active motion. But here it's going to be put to the test because this is like 1.4 million data points that I'm trying to move around. So, but I'm going to try here. I'm just grabbing it and dragging it around, and yeah, it's having a pretty hard time, I gotta say. But let's see if it'll redraw it here. I mean, it's working on it. It's just a lot of data points. One of the things that I can do is I can actually come down here and let's do every oh man, is it this one? I think it's this one, every 10. I think it's that one. Maybe it's supposed to be here. I don't use this enough to remember every single time. Now, where is that supposed to be? I don't think it's up front like this. Whoop. Sorry. Pushing the wrong buttons tonight. No. Oh, shoot. Plot file every blah. So, I wonder if this doesn't work with splot. Because yeah, I was doing that right. Well, let's just do plot and see what it does. And now I know it's supposed to be the first number, so I can just do that. And let's just do X and Y. Oh, okay, so that was every 2, but I should be doing like every 10. Oh, where is it? Oh, it rotated around a little bit. I don't know if that's the new rendering or the old rendering. Oh, okay, it's not responding. There we go. Okay, yeah, so that's a 2D plot, and that's every 2. Let's go every 10. Heck, let's go every 100. Okay, so now starting to see some interesting structures, even looking just every 100th data point on this. So we can, yeah, let's try. Yeah, Yeah, of course we can do that. Okay. So there. So now we can start rotating it around. Ooh, look at that. Ooh, that's very interesting. Let's go every 200. Ooh, look at that. Wow. Let's make this a little bigger. Really see what's going on here. So this is the magnetic field strength in X, right? In X, Y, and Z of this spacecraft on September 18th, 2001. So I don't know anything about what this actually means, but yeah, there's some interesting structure here. There are these two main sort of bodies in this space. You know, this weird magnetic field strength space. And this is really dispersed. Looks like maybe a little bit of concentration. Hard to tell. But then this one here has this really interesting shape and these really interesting structures. So yeah, I don't know what's going on there. I mean, we're looking at these data points through time. So we can let's see. Point increment is the first number. Block increment, start point, block increment, end point. So let's see, 1 to 1,000. Nope, it's not quite it. One, two, three, four, five. I think there's supposed to be 5 there. 1, 2, 3, 4, 5, right? So I've got the point increment, which is 200, and then no block increment. So that's this first one. Starting point is 0. Starting block is nothing. End point is 1,000. And then, yeah, dang it, so that should work. I don't think that's what it's... yeah, see, there's nothing there. Okay, so maybe it's... Oh, okay, so... Yeah, no, that's exactly what I'm doing. See, this would be exactly the same thing, except I do every at the beginning. So 0 to 1,000. Maybe I do have that right. Oh, because 0 to 1,000, there'd only be five points. Well, duh. Okay. So let's increase this. Hey, is that a Bobby? What's happening? Uh-oh. Did I lose him? I lost him. Hey. What's going on over there? Can't hear you. Can't hear you. He's talking, but we can't hear him. He's going into the wormhole. There he goes. Look out. Nope, can't hear you. All right, so I'm gonna keep on going. Let me get my screen back here. So yeah, every 200, let's do the first 10,000 points. We'll have, well, a couple of points there. Let's go a little bit more. Let's go 100,000.
Hey, Cosmic!
Hey, there you are. Wow, you're really loud.
Yeah, so we just got done with our pay-per-view.
Yay! Did you have fun?
Yeah, oh yeah, what are we looking at?
Oh, how did we get onto this? Man, I'm trying to remember our path into this now. Oh yeah, PageMaster pointed out that the Deep Space Network was looking at Voyager, so we just decided to go over there and see, what was up with all these things and talk about this a little bit. And one of the spacecraft that is being talked to right now is a spacecraft called Geotail. And it's out there going around the Earth, measuring the magnetic field of wherever it is. And so we went over to their website, and there was a thing to extract, some data. And so we're just looking at the data. So you're all caught up. So here it is.
Okay, I'll still be watching it.
Yeah, good. So here's what we have so far here. And let me see what happens if I use lines instead. Lines, line width 1. Yeah, that doesn't look quite as good. Let me make these maybe a little bit bigger. Oh, there we go. And sort of see it in 3 dimensions there. But these are all connected in time too. So that is one element here that we're not seeing. The only way to really see that is to plot each one all by itself. So we can do that. 2001. We can do the every 200. That's fine. In fact, we can do this whole thing here. But let's just use 6 with points like that. So if you do it that way, it might be easier to do it with lines. Lines, line width 1, line color black. So there's how the X component of the magnetic field changed over time. At least the first 100,000 data points. Each data point, I think, we can actually look at that. So, grabbing my handy dandy
Where's
calculator here.
Alta, by the way? Where's Alta?
Oh, I don't know. I don't know. So let's see. I think these are 1/16 of a second exposures, but let's find out. So let's do like 8.132 minus 0.069. So that's 0.054, which okay, so that's 0.054. Let's look at another one. So 257 minus 194. Oh, 257 minus 194. That's 0.063. So it seems to change a little bit. That's unfortunate. So, yeah, what I'm trying to represent here isn't exactly right, because I'm not going to be able to figure out exactly what time it is here. This is just the data point number. And if you go from 0 to 100,000 and look at every 200 of them, then you're going to have 500 data points. So, but we can look at the whole thing. Might be interesting.
So 2 things happen, according to Top 10 Scholar. Everybody, by the way, on this day in 1969, Apollo 10 launched. The mission set the stage for astronauts on the moon during 11. And also, in 2009, the 23rd and final Hubble servicing EVA took place.
Very cool. Yeah, I heard that Apollo 10 could have actually landed on the moon if they were so ordered to do so. I think they were ready to do it. I think. But yeah, pretty amazing that they did Apollo 10 in midish May, and they did Apollo 11 in July. So May, June, July, like 2 months apart. So that's pretty amazing. Anyway, so here's how the X component of the magnetic field changed approximately over time, over the course of a day, September 18th, 2001. Just arbitrarily chosen. So we can look at the X component, we can look at the Y component the same way. I don't know if the scale changed here or not. We could find out.
I think I also scared everybody away because there's 2 people watching.
Oh, you scared everybody away?
Yeah.
Oh well, they are missing out on just incredible things here. So let's go from
Now, out of my curiosity, when your BOD usually becomes shorter than Geo's, right?
My what?
Let's say you just finished up and it usually becomes available on the spot, right?
I'm only hearing every other word, Bobby, so I'm not understanding you at all. Sorry.
Yeah. Let me. I'm gonna kill. I'm gonna Well, already background in my Discord. Why is it doing that?
I don't know. Anyway, here's the Y
Yeah.
component.
So again, I was saying is um, as soon as you go off the air, the on demand is on the spot, right?
Um, I'm not hearing you really, really well. I missed the last
Yeah.
part.
Um.
Sorry.
I'm the router. I'm gonna reboot the
Yeah,
router.
you are breaking up. Bobby is breaking up. So I'm going to plot X, Y, and Z all on the same plot here. And, oh, well, all right. I'm not going to do that. I'll have to do it this way. This screen does some pretty weird things, but we're good now. Okay. So here's the, well, where is it? There we go. So there's X, Y, and Z. So X is the black, Y is the red, and Z is the blue. So we can actually go from -50 to +50 instead of 100 to 100. Let's see if I can do this. 1, 2, 3, 50. I'm gonna have to do this in a couple of steps. This screen gets into a weird mode. 1, 2, 3, 50. Okay, there we go. So yeah, it just sort of looks like towards the end of the day, it got into some kind of wild area where magnetometers were testing some pretty strong fields. See, these are, well, you know, upwards of 30 nanoteslas. So I don't know if that's a lot or not, but this sort of looks like sort of nice calm around 0. But then there's all that, and then of course we can go back to the 3-dimensional parts here. 6, 7, 8. Let's look at what's that? See, so it's still all those are there. So let me make this a little bit smaller, 0.5 maybe. Here we go. It's pretty interesting structure, which I can appreciate. So this is just the XYZ magnetic field strength over the course of a day. So we can definitely make those with the line. So if you can follow the line, that would be where the field is going. But I think this is going to be pretty messy. We can do points and lines. Maybe it's called lines points. I never remember this stuff. There we go.
Woo!
Yay, he's back.
Yeah, I had to reboot.
Wow. Let's see.
Yeah.
0.25
So,
maybe?
your So your on demand is supposed to be instant when you go off the air, right?
Um, I think it's pretty instant.
Yeah, because
I think it is.
Geo's is
Yeah.
usually not.
Okay. Yeah. I don't really pay that much attention, but I don't think it's. Yeah, I don't think that there's really any kind of delays or anything. Not that I'm aware
Right.
of.
Yeah, because you're doing Hangouts, Juice is doing a special way, which I think is YouTube's recommendation.
Okay. Yeah. Yeah. I just I sort of determined that this was the easiest um, means of entry. So and it is. It's super easy. I recommend it.
Yeah, yeah.
So let's see. Let's what else we can do here? Let's go from 500,000 to the end. Whoop! I missed one. Yep, I did. One, two. There. Oh no. What am I missing here? 5,000. Huh, what am I missing? I should have got that right. Now that one works. So now I want to go 50,000 here.
Maybe you should do a 0.
And nothing here. It's not letting me do that though. Arr, arr. I don't know how to. I thought I could do it from a particular place to the end. Let's put in. Yeah, see, I can do it that way. Dang it. Let's see if I can. Let's see. We'll go 1,000,000 to 1,000,004. Yeah, that's when it starts to get interesting. I guess this is this the early stuff? I guess that is the early stuff because look, it's all around 0. So this is the early stuff, and this is the excited. When it's bouncing around a little bit more. Interesting. What was it? Lines points, line width
Out of my
1.
curiosity, is there supposed to be a meteor shower around the weekend or something?
Oh, I don't know. Not
Yeah,
sure. Not sure.
because the live meteors echo live stream is just turned itself on.
Oh, okay, cool. So this is kind of interesting. The lines connect the data points in time. So as you can see, I mean, it sort of looks like, I mean, you can't really see the path, but you can definitely see that there's some structures in here. Interesting little things when you connect all the dots. That's all I'm doing here is connecting the dots. Let's make those a little thinner, maybe, if I can. Oh, that's a little too thin. You can spend hours messing with this kind of stuff. There we go. That might make a pretty interesting stereoscopic image. So I might do that here while I'm. I think I'm going to go over to check me out, and listen to some singing bowls. Yeah,
Oh, she's on tonight.
I think she is. Yeah, I
Oh,
think
okay.
so. So yeah, I said I was going to end this a little bit early. I think this is probably a good time. Now, this was a fun tangent. I like doing this. I really, really like looking at data in sort of unusual ways. Um, and this is pretty interesting. Pretty interesting what's going on here. I don't know what it means. I don't exactly know, where this was in reference to the Earth. Um, but it is over the course of a day, and yeah, just kind of interesting. Kind of interesting. So yeah, I think I'm gonna mess with this a little bit more. I'll make a 3D thing out of it, and well, see what that looks like. So for now, I have definitely not drunk enough of this incredible fluid here. Got completely sidetracked, which I totally like, as long as it's, space, astronomy, nerdy things like that. We here pretty much forget about everything else, at least during this time, and we look at some cool stuff. So okay, well,
Yeah.
great. I think I'm gonna end for today. There will be a tomorrow. That has been my experience in the past, and I don't have any sense that that's going to change anytime soon. So yeah, I will be here again tomorrow, 2 hours UTC, doing some more astronomical stuff. Who knows what we're going to do? Um, I really don't make any kind of plans or anything. I know that we're talking about the constellation Aries, um, and I think we're just going to slowly move through that constellation. There's always lots to talk about. Different objects, different kinds of objects. So yeah, even a relatively small constellation like that, we've got several days at least of things to look at with that. So all right. Well, I think for now I'm going to get out of here. So Bobby, it was great to have you popping in at the end there. Excellent.
Yeah. Yeah.
Excellent.
And
All right.
I'm
So
gonna give it like about 5 minutes before I find out if the VOD is gonna be available.
okay, very cool. All right. So I'm going to get out of here for now. So peace, cheers, and all that. Everybody live long and prosper. And I will see
Alright.
you once again on one more spin. Take care, everybody. Bye.
Later.
Uh,